Today I'll be presenting our project. Uh, our project title is ETL processing on Google Cloud using Dataflow and BigQuery. My name is Gautam Bhattacharya and we are a group of 4. So I'll be stating the problem statement. In today's data-driven landscape, organizations deal with vast volumes of structured and unstructured data that need to be efficiently ingested, transformed, and analyzed. Traditional ETL processes often suffer from scalability issues, inefficient resource management, and high operational overhead. These problems are compounded when handling real time data streams or large scale batch processing. The relevance to cloud computing lies in leveraging scalable managed services like Google Cloud Dataflow and BigQuery, which reduce infrastructure management, enable parallel processing, and integrate seamlessly with other cloud native tools. Addressing ETL inefficiencies directly enhances the data accessibility, decision making, and operational agility. Literature references are Google Cloud Dataflow Model and a survey of ETL tools and cloud performance, IEEE 2020. Then optimizing data pipelines with Apache Beam and Dataflow, Google Cloud Blog 2021. Then BigQuery Cloud Data Warehouse for Analysis, Google White Paper. Limitations in existing approaches. On-premise ETL lacks elasticity and incur high maintenance costs. Traditional batch-only models are not fit for real-time applications, and some tools require steep learning curves or lack portability across environments. Existing results. Study in Akida et al. Tools data flow. Throughput is high, latency is low, scalability excellent, cost efficiency moderate. IEEE survey, Talent Informatica, throughput moderate, latency high, scalability moderate, and cost efficiency low. In Google Blog Dataflow Python SDK, throughput is very high, latency is very low, scalability is excellent, and cost efficiency high and can be optimized, which can be optimized. Next, there is a graphical representation of throughput and latency. It is a visual comparison given. How to implement? Implementation platform is Google Cloud Platform. Technologies are Apache Beam, SDK, Python, Dataflow, BigQuery, Cloud Storage. General steps are uploading a raw CSV data to a cloud storage bucket. Create a data flow pipeline using Apache Beam and Beam Python SDK. Extract data from cloud storage. Apply transformations. Example, parsing, schema mapping. Load transform data into BigQuery staging table. Use SQL in BigQuery to enrich and transform the data into a final analytics ready format. Services and features used. Cloud storage for raw data ingestion, Dataflow for batch data processing, BigQuery for transformation and storage, IAM for access control, monitoring via cloud logging. And now we'll go to the detailed step-by-step instructions. To do that, we have to build and run a Dataflow pipeline, Python to ingest data from cloud, storage to BigQuery, then build and run Dataflow pipelines, Python to transform and enrich data BigQuery, and third, there's a build and run Dataflow pipelines, Python to join data in BigQuery and write the results of the new table. Setup requirements. We have to create temporary credentials to use to sign in and access Google Cloud Platform. And now we have to open Google Cloud Console. It's better to use an incognito window. Then you have to follow the subsequent instructions. Accept terms and conditions. Do not add recovery options to full authentication, and do not sign up for free trials. Now we have to activate first the Cloud Shell. The Cloud Shell is a virtual machine that is loaded with development tools. It offers a persistent 5 GB home directory and runs on the Google Cloud. Cloud Shell provides command line access to your Google Cloud resources. First, we have to activate the Cloud Shell, and then at the Google Cloud Console. Click through the following windows. Through the Cloud Shell information window. Authorize Cloud Shell, use your credentials. We have to use our credentials to make Google Cloud API calls. When I'm connected, you are already authenticated, and this message will be shown. Your cloud platform project inside session is set to project ID. That project ID will be shown on that. The gcloud is gcloud is a command line tool for Google Cloud, and it comes pre-installed Cloud Shell and support a step completion. That's all from my side. Now,
Rahman, my roll number is G241031. So in this my project we are performing ETL processing on Google Cloud Platform using Dataflow and BigQuery. So in this project I have done tasks 1 to 4. So after activating the Google Cloud Shell, first task was to ensure Dataflow API is successfully enabled or not. So for that, what I have done in my Google Cloud Platform, that I have searched for Dataflow API. And you can see I have already enabled API in my Dataflow. Then the second task was to download the starter code in Cloud Platform. For that we have to go Cloud Shell and implement this code. Here I am authorizing my Cloud Shell. And after opening this, we have to implement. Next we have to search for this, you can see this cloud storage bucket, and we have to create a bucket here. And we can see select area Asia Pacific, and continue. We're setting standard default settings and uniform, and finally I'm creating creating the bucket. Now here we can upload our data and transfer our data. Here you can see I have uploaded my data, and after that we have to do creating a BigQuery dataset. We have to do creating a BigQuery dataset. For that, in Cloud Shell we will run the following command. That's from my end, and next our colleague will follow. Thank you.
Hi everyone. So this is Abhirup. So I'll today walk you through on what we are going to do. So basically walk you through on the data ingestion pipeline as part of our ETL project using Google Cloud Platform, Apache, Azijur, and BigQuery. And the core goal of this stage was to build a scalable, efficient pipeline to ingest raw CSV data stored in the Google Cloud storage into BigQuery, and which is Google serverless highly scalable data warehouse. And to achieve this, we have used Python with the Apache Beam SDK to define our pipeline process. The process begins with using a text IO source and to read flags from the Google Cloud storage. From there, the pipeline filters out the header rows. It also is into dictionary objects, and then basically writes the result directly in the BigQuery staging table using the BigQuery inflow outflow IO thing. But before executing the code, we reviewed it in the Google Cloud Shell code editor. The inline comments help to understand each transformation step completely, and from passing the data, the applying schema mappings to prevent the data for BigQuery ingestion. And then the ingestion job inside a Docker container, ensuring that the compatibility with the Apache Beam and other dependency. Once submitted the data flow auto scale resources to complete the job in the first few minutes. The data ingestion happening. Finally, we verified that the data in the BigQuery also we verify the data in the BigQuery of the names. Okay, the USA names in the table lake dataset was populated as per expectation. So as part of the project, so basically as part of the project, we not only test the pipeline development skill, but also showcase how serverless tools reduce the setup complexity and processing time cost by using the text IO source to read the Google Cloud storage. From there, the pipeline will filter out. Okay, the documentation pipeline will filter out the header rows over here, and so each line into a dictionary and dictionary object, and write the results directly into the BigQuery staging table via the BigQuery inflow of the BigQuery IO, which we talked earlier. Thank you. I'll hand it over to the next person in the team to move it forward. Thank you.
Hello everyone. Today I'm going to discuss about the our project that we have focused in the two final tasks, that will be the data enrichment and the data lake and the data mart. Okay, so uh, in the task 7 we have enriched our data by cleaning the transforming and loading into the BigQuery. using the data flow pipeline after tweaking the code. And we successfully created the USA underscore names enriched table that will give us more defined data set in the analysis. Okay, and then we took and after that, then coming to the explanations, and we will build the enrichment. At the first step, we will ingest the cloud storage, and after that, we'll filter out the header row and convert the lines to the dictionary objects. And after that, we will just go for the output of the BigQuery. And in the code editor, we'll edit. We'll go for the. We have created a data for the enrichment.py. Check out the comments which will explain the code by doing the code populates, and you can we have already attached that also. And when we have finished editing lines, and we will remember the save of the after that, obviously it will save that, we'll save it, and we'll run the following code. After that, we will run that following code over here. And in the data flow page, you can create a job view status, the data flow pipeline that will start the work, then it will go for the shutdown. Once the job status is succeeded, the data flow on the job status in the screen in the console, click like the navigation menu, and then in the BigQuery to check the and see what is populated now. And after that, as I told that we have created that user underscore name underscore English dash table. And then next is the task 8. This is the final task almost. Then that we will review and run the data lake in the data mart pipeline. Now we'll go for the data mart pipeline by two BigQuery. Ingest from the two BigQuery sources, and we'll join the data sources. And after that, we will filter out the header row and convert the lines in the dictionary object. After that, we will go for the output rows in the BigQuery. Then the ingestion pipelines to perform the data join, write the resulting table in the BigQuery. Okay, in terms of result, we reduce the processing time from 30 minutes to just 5. For cost cutting is almost 40%, and that will handle almost 10 millions of records. In conclusion, what implementations using Google Cloud Data Flow, that you can in the running code, you can see that we will execute that pipeline, how we have executed that one. So the thing is that in the Google Cloud Console, in the title bar, the data flow in the search field, then we will go for the click the data flow in the search result. The data flow pipeline takes approximately 5 minutes to start to complete the work and then shut down. The job status and the exit that will succeed in the data flow job status screen, and the BigQuery to check the data has been populated. In the BigQuery, in the screen we see that the data has been populated under the table lake data set. Okay, then we'll click the table to navigate the preview to see the example. So if you don't see the denormalized table, then we will refresh the page. As a result, this is the result we have got it as a latency reduction as a cost efficiency and scalability issue. Easily you can handle the records of the no performance regulations. And in coming to the comparison analysis, the scalability is elastic auto scaling, and the cost is 40% reduced, and the latency is very high. So the complexity is a medium to high, and this is the performance versus cost comparison that we have plotted in the graph. And in the conclusion, this project demonstrated that we using the Google Cloud Data Flow and BigQuery services for scalable ETL processing by leveraging Apache Beam in the solutions. So coming to the architecture, this is the architectures of that we have